So at Facebook, we love to move fast. In fact, we pride ourselves on it. But development can have a lot of necessary evils that waste time during the day, like waiting for your code to build. At Facebook, we have entire teams devoted to building systems to help our engineers move faster and be more productive. In this next session, Katie and Casper will demonstrate some of the powerful tools we've built to mitigate some of these time wasters and optimize for a happier and more productive engineering community. Please welcome Katie and Casper to the stage.
Great, thanks. I'm Katie, and I'll be joined later by Casper. And we are both engineers in developer infrastructure here at Facebook. So it's our job to ensure that Facebook's engineers have the freedom to move fast. Now, optimizing for the speed of Facebook's engineers is really useful, not only for Facebook's sake, because we benefit so much from the work that our engineers do, but also for the sake of our engineers, because I can say from personal experience that our engineers are happier when they have the freedom to move fast. So let's take a look at what the ideal developer workday might look like for a Facebook engineer. I would say that ideally, our engineers have long, uninterrupted periods of time when they can really focus, when they can reach that state of flow that's so critical for doing really great work. This is the time when our engineers are free to write code, to brainstorm new ideas, and to iterate on the things that they're really excited about. Unfortunately, the developer workday is often fragmented by time spent waiting on machines. So it's our job in developer infrastructure to remove as much of this time waiting on machines as possible, so that ideally, our engineers can accomplish more in the same time period, and they also feel happier with their jobs. Now, I work on developer efficiency for web-based development at Facebook in particular. So let's take a look at some examples of the kind of things that our engineers might be waiting on. The first thing that comes to mind for me is the build. I bet that everyone here in the audience has had those moments when they're staring at their watch, wondering when on earth is this build going to be finished. But then, as the company, the size of the code base, and the number of engineers all grow, we start to encounter problems of scale. We introduce solutions to help cope with scale, and if we're not careful, those solutions can also start to slow our engineers down. Now, tackling those problems helps with a single code change. But there is also a lot of time that gets wasted as a result of context switch overheads. Ideally, we'd like our engineers to be able to move from one task to the next without getting stuck waiting for any major bottlenecks. So I'm going to talk about the ways that we've removed many of these bottlenecks from our engineers, so that our engineers have long, uninterrupted periods of active development time. Now, as I mentioned, I work on infrastructure for web-based development here at Facebook in particular. And as Dwayne mentioned in the prior talk, we used to be a PHP shop. Now, you might be looking at this slide and thinking, OK, PHP does not require a build. What are you talking about, Katie? But PHP was too slow to keep up with Facebook's growth. So we did actually introduce a compile step. It was called HPHP. We converted our PHP code to C++, and then we compiled the C++ code using GCC. This made production faster, but our engineers could not use it. It was too slow. So we had a situation where our development environment differed from production, which you don't ever want, and our poor engineers were still stuck waiting on too slow PHP. So this is when we introduced HHVM. HHVM gave us a JIT that was fast enough for production, but it also compiles incrementally. So that means our engineers don't have to wait on that too slow build. So we had the same development environment as we had in production again, and it sped up both our production workloads and our developer workflows. So this was awesome. Now, we've been using HHVM for a while here at Facebook, but what's really important about it in this context is that HHVM made this edit and view cycle, where our engineers can make changes to Facebook's code base and then immediately go view the results in their web browser. It made that cycle possible at scale. So something that we've been thinking about a lot recently is how React Native can allow our mobile engineers to have that same benefit of iterating quickly. React Native basically gets rid of the build for our mobile engineers so that they too can have this fast cycle of making changes to the code base and then immediately reviewing the results. So this is awesome for keeping our engineers both productive and happy. Now, pulling the build out of the engineer's workflow is really useful for one engineer who might build 5 to 10 times a day. But as we scale to thousands of engineers and to over 1 billion users, we encounter problems of scale. So we introduced tools to help cope with scale, both to maintain runtime efficiency, but also to help our engineers cope with the growing code base. And if we're not careful, these tools can slow our engineers down. So I'd like to give you some examples to help make this a little bit more concrete. Static resources is a term that we use here at Facebook to refer to code that we bundle up and send to the browser, like CSS and JavaScript code. Now, we have a lot of static resources here at Facebook, and they can be fairly large. So we have a system to automatically manage these resources for us. The site has to be fast, so this is great, because we can automatically optimize these resources for size and performance. But it also makes our engineers fast, because it hides complexity from our engineers, so they don't have to worry about managing these resources. But as our engineers make changes to the JavaScript and CSS code, the system has to be updated. And the time spent waiting for those updates can really start to add up. Another great example is automatic code generation. Now, if you were here this morning, you might have heard a talk about GraphQL. GraphQL is a really good example here because it allows me, by writing a small schema, to generate a type-safe, performant, and fully featured API. So this is really useful for a growing code base. But the time that our engineers spend waiting for code generation to happen can really start to add up. Finally, we introduced services to help our engineers deal with the growing code base. And a great example of this is the hack server that Dwayne talked about in the prior talk. Now, strong typing is really useful. It helps us avoid security errors. It makes it possible to do large refactors safely. It ensures we're using the right APIs, and it even makes our code self-documenting. There's so many reasons to use the hack server. But the time spent waiting on that type checking can really start to add up. So we have a general approach to solving these problems here at Facebook, and it's twofold. First of all, wherever possible, we background these updates so that our engineers don't have to wait on them explicitly. And second, wherever possible, we make incremental improvements using save state from prior invocations. So to make this possible, we use a tool that we've developed here at Facebook called Watchmen. Now, Watchmen is an open source tool, so you should definitely check that out. And what Watchmen does is that it watches the files in the repo, it records changes to those files, and then it can trigger actions in response to those changes. So if I make changes to CSS or JavaScript code, there's a background process that can record those changes. It makes incremental updates to the static resources. And then when it comes time for me to view the page, we can lazily load only the changes that are needed on demand. Similarly, if I make changes to a GraphQL schema or other inputs to automatically generated code, then a work that we have in progress right now is making it so that the system can, first of all, let me know that I need to run code generation. But second, it can generate only the files that are needed based on the changes that I've made. And third, we could actually automatically generate the code for you in the background, so that basically code generation becomes a non-issue for our engineers. Finally, as Dwayne mentioned, the hack server, when I start it up, will load save state from a known good revision in my source control history, so that then when I change hack files, it only has to reason about changes that I have made to the code. And then when it comes time for me to view the page, I've got fully type-checked code ready to go almost immediately, though I still have to go back and fix any type errors myself. So backgrounding with incremental updates has gone a long way to help solve these problems. But as the code base grows, testing also becomes a bottleneck. So our general approach here has been to offload this testing work wherever possible to our continuous integration system, which is called Sandcastle. Sandcastle is a tier of machines and services built on top of them that build and test all of the changes to Facebook's code base. And I actually gave a talk at F8 several years ago about Sandcastle. And that was also about ensuring that our engineers aren't waiting on machines. And then we were focused on finding bugs as early in the development workflow as possible. And that's still really important. But our recent focus has been on removing these same bottlenecks from our engineers in Sandcastle as well. So we pre-compute static resources like CSS and JavaScript and operate only on the changed files in Sandcastle. We actually check into the repo our automatically generated code. So we don't have to wait on code generation because the files are already there in the repo. But what's key about this is that we actually automatically handle merge conflicts for you. So if two engineers check in changes to the same automatically generated code, then we'll actually resolve that for them so that they never have to worry about it. And finally, we prefetch saved state in Sandcastle for the hack type checker, so that when you put up your changes to the code, we only have to reason about the files that you've modified. So together, these optimizations have saved us thousands of hours of engineering time every week. And this is awesome because our engineers are free to use this time to build new things, to brainstorm new ideas, and to work on the things that they generally find a lot more fun than waiting on machines. So we've solved waiting on machines for a particular code change with this workflow. But sometimes we're not waiting on machines. Sometimes we're waiting on other engineers. So maybe I need to wait on one of my coworkers to review one of my diffs. Or maybe I'm building something on top of something that one of my coworkers is doing. Or maybe I'm just done with this task and I want to go work on something else for a while. This is when context switch overheads start to become a problem. We'd really like our engineers to be able to move from one task to the next without needing to wait on machines. So the first thing that comes to mind for me when I think about context switch overheads is source control. Now, if you're used to a relatively small repo with relatively few engineers, then source control operations may not seem like a very big deal. But as the size of the code base, the number of engineers, and the size of a given rebase all grow, those source control operations really start to add up. And this is true not only because the set of files we have to change can get very large, but also because changing branches makes our resources stale. So all of those operations that we hid from you so that our engineers weren't waiting on them, well, they start to become bottlenecks again. But I mentioned that we've got a Sandcastle host already warmed up, ready to run tests on my code. So something new that we're working on right now, and that we're just getting started rolling out, is making it so that we've got a Sandcastle warmed up and ready for active development. To make this really seamless for our engineers, we've leveraged our IDE, which is called Nuclide. And that's publicly available, so you should definitely check that out. And we've made it so that we've got a warmed up Sandcastle ready for interactive development at the click of a button. And in fact, can have multiple. So when I look at my changes to Facebook's code base, I see a Nuclide button right there, ready to go. And if I click on it, I get a Nuclide server connected to a Sandcastle host with a development environment that's totally ready to go. And there are a lot of really awesome advantages to this workflow. So first of all, it basically eliminates maintenance time for our engineers. So if something's going wrong with this server that I'm working on, if it starts getting really slow or something, I can just throw this machine away and go start working on another one. We're constantly backing up my changes so I can move to a new machine almost immediately. Another great advantage is that this makes our code really shareable. So not only is my code immediately available for me to look at and make changes to, but my coworkers can also patch my code, they can test it, and they can build new things on top of it. So it's awesome for collaboration. And finally, the service is truly available on demand. So this means that there's no startup cost. All of that context switch overhead that I was talking about, that's gone. I can also start up multiple at the same time, so there's never any need to prematurely commit my changes to go work on something else. And we also get better hardware utilization, because as soon as I am done using this machine, it starts getting cleaned up and prepared so that somebody else can start using it. So there are a lot of advantages to this workflow, but it also introduces some new challenges, because now I'm doing interactive development with a remote Sandcastle server. So Casper is going to join me now, and he's going to talk about how we've solved some of the challenges that working on a remote sandcastle server presents.
Thank you. So remote development setup that Katie described solves a lot of problems, but it also makes building some interactions that we often take for granted much more trickier. One example that I will focus on is building a robust and responsive IDE. As was mentioned, at Facebook, the IDE of choice for many engineers is Nuclide. Nuclide is built on top of GitHub's Atom, and we use the same editor for many languages. For Hack, Flow, C++, Python, some crazy people, like my team, code in OCaml, and many others. It's very extensible, and a lot of care was put to adapt it to Facebook environment. So for many engineers, it is the entry point to this entire system that we describe. So what are some of the things that we expect from a good IDE? Well, there are many answers to this question, but one particular that I will focus on is that we expect it to provide you with feedback. We expect it to show diagnostics, errors, informations. And we want this feedback to be immediate, to show up as soon as possible, preferably the moment you stop typing. And we want it to be accurate, to be consistent with the results you will get later on from compiler or from runtime. So in our setup, does it work like that? It turns out that making stuff remote introduces a lot of micro interruptions. So for example, the diagnostics no longer show up immediately, but it takes a few seconds. The autocomplete results can get out of sync. And we are talking about seconds here, but over the course of the day, it adds up, and it's a drag on your focus and productivity. Here's an example of such interactions from one of the early versions of our remote IDE. We're going to try to add a new method to a class. Notice that as we're typing, the diagnostic pane below is empty. There's no feedback about what's going on. In fact, we are just going to make a mistake, but we're not going to know about it now. When we try to use our method in another class, it doesn't show up in autocomplete. So we have to go back. We save the file, and some time passes. And only now we know about the error that we made before. So we go back, we fix the error. We remember to save the file this time, but the error is still there. So the time passes again, we wait, the error is gone, and only now we can resume what we wanted to do in the first place. So we just wasted a ton of time going back and forth, waiting for stuff. It's not the experience that we want. So why is it happening? Why doesn't it just work the way we expect it to work? It turns out that most IDEs very strongly assume local development model. So they assume that the files and editor are on the same machine, that the files can be accessed, and traditionally, IDEs also duplicate a lot of the compiler's work. So they have a language component that knows how to parse files to display errors. It knows how to infer types to provide intelligent completions. In our setup, we had to move most of those things to a beefed-up remote development server or to Sandcastle. So not only the files cannot be freely accessed, the size of the Facebook code base and the scope of dependencies in it would make it very unlikely that the local editor trying to locally duplicate the work that the remote compiler is doing would lead to a responsive experience that we are looking for. So in the video that you've seen, here's what happened behind the scenes. As you open the file and start typing, the compiler is completely unaware of it. Only when you save the file and its contents are synchronized to remote system, the compiler can notice it. But it still doesn't know much about the editor. It just knows that the file has changed, so the only thing it can do is to reanalyze it and all of its dependencies, while the diagnostics are piped back to the editor to be displayed. So as you can see, the time from edit to getting any feedback can be counted in seconds. You need to save the file, and it's just not what we want. This is where all those interruptions are coming from, and we wanted to get rid of them. So how did we do this? Well, we started by revisiting the relationship between the developer, editor, and the compiler. Traditionally, this relationship between the developer and compiler is an adversarial one. So the developer tries to write code, and the compiler punishes them for making mistakes by spitting long lists of incomprehensible errors that need to stop, take time to read and understand, go back to the code that you are already done with, fix your mistake, rerun the entire process to make sure that you really did fix it. On the other hand, IDE tries to be your friend. So it allows you to avoid an entire class of errors by providing autocomplete. It guides you as you code by displaying function signatures and parameter types. If you do make a mistake, it informs you about it as soon as possible. It does it in an understandable, visual way. It can even offer to fix the mistake for you. They are also often architected very differently, with the compilers focused more on a batch use case, and the editors working in a more fine-grained and incremental manner. So we have this awkward situation where we have the compiler, when we have the editor that wants to help you, but it lacks the means, and the compiler that has the means, but is not really working to help you. In fact, it doesn't even know about you. It doesn't know that it's being used for the IDE purposes, so it doesn't care. The solution here is to make them work closer together and both being your friends. And we do it using something we call persistent connection between the editor and compiler. So in this setup, the moment you open the file, the editor will establish persistent connection to the compiler. And from now on, the compiler is constantly aware of what's going on. So it's aware of each of your keystrokes the moment you make it. It's aware of all the files that you have opened, aware of the errors that you're already seeing. And that allows it to work in a much more smarter way. For example, it can prioritize quickly analyzing the file that you were just looking at and pushing errors for them first. And this leads to this quick feedback loop that we were looking for. Only at a later point, when there's a bigger break in activity, the compiler can also notice it and take advantage of it to analyze other files and deliver results for them in an incremental, asynchronous manner. So you're getting feedback much more often, and the time from edit to feedback has been drastically reduced. Let's see what it does for your productivity. Here's the comparison. On the left side, the video that you've already seen, and on the right, the version using persistent connection. Notice that now, as we're typing, the diagnostic pane is alive. You're getting feedback about what's going on all the time. We're going to make the same mistake as before, but we know about it immediately. So you just quickly fix it. The error disappears. No need to save the file or wait for anything. We can use it at another class, and autocomplete works the way we want it, and we're done. While the left side is still going on back and forth, synchronizing stuff, waiting. So this is the experience that we want. This is the experience that we expect. And we are proud to be able to offer it to our engineers, no matter what is the scale that they need to work on. For the Facebook codebase, we've been able to reduce average time to feedback from being counted in seconds to being less than 200 milliseconds, which is the difference between mildly infuriating and basically imperceptible to the users. And it really changes the way you work with the editor and how you think about writing code. So now, you are really doing your job without any interruptions. We've implemented this approach for Nuclide and Hack, and we're working on making Flow work in similar way. All three of them, Nuclide, Hack, and Flow, are available on their respective websites. I invite you to check them out. And if you have any questions, you can find us later in Developer Garage. Thank you.